Hello everyone, this is Dr. K. Amuda, Associate Professor, Department of Physics, RMD Engineering College. In this video, I am going to discuss about light emitting diode. Light emitting diode can be called as LED. Principle. It is a device used to convert the electrical energy into light energy. Light emitting diode, as the name indicates, it is basically a PN junction diode which is able to convert electrical energy into light energy. When it is forward bias, when the PN junction is forward bias, the majority charge carriers of the electrons from N-type and holes from the P-type are diffused into each other. At the junction, the electron-hole recombination takes place and the energy is emitted in the form of visible light and infrared region. Depending upon the band gap of the material used, it can be the light can be emitted in the visible region or in the infrared region. Now let us see about the construction. The light emitting diode is basically made by gallium arsenide semiconductor. First, the PN junction is formed by epidaxial growth technique. Here, the same silicon material is being taken, and when it is doped with the gallium, it will turn into a N-type semiconductor. And silicon is doped with arsenide, it will turn into a P-type semiconductor. And hence it forms a gallium arsenide semiconductors. The thickness of this N layer is always larger than the P layer because of increasing because to increase the radiative recombination. Proper electrical connection, forward biasing is given to the semiconductor through the aluminum contact. That is, P-type is connected to the positive of the battery and N-type is connected to the negative of the battery. PN junction is slightly open for outcoming light rays. When the PN junction diode is forward bias, let us go with the working. The barrier width is reduced, raising the potential energy on the N-type and lowering that on the P-type. The free electrons and holes have sufficient energy to move into the junction region. If the free electrons meets the hole, it recombines and releases a photon. Thus, light radiation from the LED is caused by the recombination of holes and electrons that are injected into the junction by the forward bias voltage. Now, whatever we have discussed before, we just look into this. This GIF will show you the biasing conditions of this PN junction diode. So here the P type indicates the P-type semiconductor and N-type indicates the N-type semiconductor. Hence the PN junction diode is formed, and this is what is called as a junction region. So when P-type material and N-type materials are joined together, then you can see that there will be a depletion region forming in between the two semiconducting materials. And this GIF will tell you during biasing what happens to this depletion regions. So when the N-type is connected to the negative of the battery and P-type is connected to the positive of the battery, it is called as a forward bias. So during the forward bias condition, you can see that depletion region is decreasing, and whereas during the reverse bias, the depletion region increases. Reverse bias meaning N-type is connected to the positive of the battery and P-type is connected to the negative of the battery. You could see the depletion region is increasing. Okay. Here the dots is nothing but the electrons and minus and this hole is this hollow sphere what is being shown in the diagram. So as soon as this P and N materials are joined together, you can see the crossing of charge carrier taking place. The black dot is going towards a P type and this hollow is going towards the N type. And and then you have the depletion regions, immobile charges being set up on either side of this junction, and this is called as a depletion region. You can see that it is forward bias. So P type is connected to the positive of the battery, N type is connected to the negative of the battery. Okay, you can see this is a energy diagram, and you could see the electrons in the N type crossing the junction and moving towards the other side, and the holes crossing the junction and moving towards the other side. Then at the junction, the electrons and holes recombines, and you get the emission of light. Now you could understand better by this GIF. Okay, so you can see that this blue color is the P-type semiconductor and this green color is N-type semiconductor. N-type is being connected to the negative of the battery. P-type is connected to the positive of the battery. So it is called as forward biasing. And you could see that when you increase the voltage of this battery, the crossing of charge carriers is taking place, and at the junction you can understand the recombination of electrons and holes taking place, and which emits light. Not only in the junction region, even on the other side of the P and N type material also you have the recombination of electrons and holes taking place, and this will give you as a light. And you could see here you have the emission of light at the junction and also on either side of the P and N type material. So here N region, this is a conduction band, valence band, and in between the energy difference is called as a band gap. And N type is the majority charge carriers are electrons, and in the P region the majority charge carriers are the holes. Holes are indicated by the positive and the electrons are indicated by the negative sign. And as soon as the forward biasing is given, the crossing of charge carriers across the junction takes place. The electrons combines with the holes and the photons are emitted. Now let us see the advantages of LED. It is very small in size, less cost and long lifetime. It needs less voltage for operate. Disadvantages of LED. It requires high power. Its preparation cost is high. Now this is a LED symbol, top view, and you can see the symbol cathode, anode, and it is a basically a PN junction diode. So you have a symbol like this, and you could see that the arrow coming out which indicates the light energy emitted from the PN junction diode. Planar and dome shaped LED. Planar LED, and this is what is a dome shaped LED. And if you see this picture A, some light suffers total internal reflections and cannot escape. So you could understand here on a substrate N and P and N type materials are being grown, and where during the recombination of electrons and holes light is emitted. And when light comes out here, then it meets the core cladding interface at the lesser than the critical angle. So it undergoes total internal reflection and most of the light gets lost, and it cannot escape. Whereas when you think about this dome shaped LED, then this internal reflections can be reduced to a greater extent. So there are two ways of forming this dome shape. One is shaping the semiconductor into a dome so that the angle of incidence at the um, interface will be smaller than the critical angle. Okay. On the other hand, if you see that the P-type material itself can be made in the form of a hemispherical dome. So these are the dome-shaped LEDs are commercially available LEDs, and they are shaped in such a way that to reduce the internal reflections. Either the P and N type materials are being covered with a plastic dome like this, as shown in this diagram C, or the P material is made in the form of a hemispherical dome. By these two ways, the internal reflections can be reduced to a greater extent. These are the applications of LED. It can be used in road signals, railway signals, digital displays, LED TV, or any segment display. So you could see here LED bulb and LED TVs and mobile display and all that. LED can be used. Thank you for watching.